Welcome back, everyone. In this video, we'll be discussing the intermediate value theorem. Now, the intermediate value theorem says that if you have some continuous function on a closed interval a to b, and if you have any number, say n, between f of a and f of b, then there's at least one number c in between a and b, such that f of c is equal to n. Now, I know with all those words and letters, it can sound very intimidating and very confusing, but it's really not too bad. And take a look down at the picture and I'll walk you through it. All this statement is saying is if you have a continuous function like the blue function there, it's impossible to go from f of a down to f of b without crossing over n. That's all it's saying. And that's because this function is continuous. You have to cross over not only n, but every point between f of a and f of b. And now if you take that and look back at the statement, I do think the statement will make a little bit more sense. Now, this definitely only works if the function is continuous. If the function is not continuous, you might not have that same guarantee. So take this piecewise function. It certainly is not continuous, and we can see that it does not cross over the x-axis, and so we don't get that guarantee that it crosses over every point from a y value of -1 to a y value of +1. Now, one very intuitive, although kind of silly example would be talking about height. Now, at birth, I was 1 foot and 10 inches tall, and now in 2021, I am 6 foot and 3 inches tall, and height is a continuous function over time. You can't skip a height. You get every height in the middle. And so, by the intermediate value theorem, at some point in my life, I was exactly 3 feet and 4 inches tall. No more, no less. And that's because if I start below that and end above that, at some point, because height is continuous, I had to have crossed over that point, as well as every other height in the middle. But for whatever reason, 3'4", wanted to specify. Now, in a more mathematical context, we can use the intermediate value theorem to guarantee that there are roots of an equation in a certain interval. And when we use the word root, all we mean there is there's a solution to this equation. There's some number I can plug into that equation to make it true, specifically in the interval 1 to 2. And I don't know how to factor this thing. I certainly can't use the quadratic formula because it's not a quadratic. And so we're going to use the intermediate value theorem. And the first thing to write out is turn this thing into a function. So write f of x is equal to x to the 4th plus x minus 3. And if I plug in the endpoints, say plug in 1 and plug in 2, when I plug in 1 and I simplify that, I get -1. And when I plug in 2 to that function and simplify it, I get 15. And the important thing here is that this function's continuous because it's a polynomial. All polynomials are continuous. And when I plugged in 1, I got a number less than 0. When I plugged in 2, I got a number greater than 0. So somewhere in between 1 and 2, there has to be some value c that when I plug it into the function, I get 0. Because if I, at one point below 0 and one point above 0, somewhere in the middle there, I have to cross through 0 because this function's continuous. And so this is another example of the intermediate value theorem. Now let's look at this graphically, and we can see that there's 1 point below the x-axis, 1 point above the x-axis, and of course we have to cross through the x-axis at some point because the function's continuous. And so when you do problems like this, you should note all three of these things: that the function's continuous, that you have 1 point below the x-axis, and 1 point above the x-axis, and so there has to be a root in that specific interval.